Good morning. In this lecture, we are going to learn Euler graphs. So, Euler graphs actually is related to the Konigsberg problem. So, in the class, we have discussed it. You can remember that there were 7 bridges, and you had to start from one point and cover all the bridges and end with the same initial point. And we were struggling at that moment, but Euler solved that problem. Here we are going to learn what is Euler graph. So to know Euler graph, we have to know what is Euler circuit first. So Euler circuit is a circuit which contains all the edges. Now you know the difference between cycle and circuit. So here vertex repetition are allowed. Okay, and if you are considering a trail, then the initial and the ending vertices should be different. For the circuit or cycle, the initial and terminating vertex should be same, but in the case of Euler circuit, vertex repetitions are allowed. For the cycle, it is not. So we are considering Euler circuit. First of all, check this graph A, B, C, D with the 4 vertex. Now Euler circuit does not exist. You can try. Let us suppose A to B, B to C, C to D, and D to A. But in that case, the edge BD is missed. Now you can try in your own way to find a circuit, and edges should not be repeated. That is the only one condition. Now look at the second picture. Here you can find a Euler circuit. So A to B, B to E. Sorry, I have misleaded the way. So you can start from A to B, B to C, C to D, D to F, F to B, B to E, E to D, and D to A. So this is a complete, you can say, a Euler circuit, because this circuit contains all the edges. Is it clear? Now look at the third picture. There is no cycle at all, so you will not find a cycle and then Euler. Now I hope it is clear that what is Euler circuit. Now we are going to the definition of Euler graphs. Euler graphs are those graphs where Euler circuit present. Now check this example. Is this graph Euler or not? So our task is to find a circuit which contains all the edges. So it is you will find a circuit. Let us suppose B to A, A to C, C to E, E to D, D to C, and C to B. So this is a Euler circuit as it contains all the edges. Now there are some properties of Euler graph. So first, a connected graph is called Euler if and only if all its vertices are of even degree. So I mentioned in the class that if you are going to certain place and to come back that place, you must have another bridge to avoid the first bridge. So that is why coming and going, so the number should be even. That is why if the degree is even, then the graph must be Euler. Now semi-Euler graph, it is also in your syllabus. Semi-Euler graph, you have to understand that. So to know semi-Euler graph, you have to consider Euler trail. So where Euler circuit is not present but Euler trail is there, then that graph is said to be semi-Euler graph. Look at this graph. You will find a Euler trail, and you will not find certainly a Euler circuit. So if you try, then what is Euler trail? Euler trail is a trail that contains all the edges of the graph. So only the difference is starting and ending vertices are different. Now A to B, B to C, C to D. Oh, I'm again misleading. So you have to find A. So you have to start from B, then you can complete. So B to C, C to D, D to B, B to A, and A to D. That's is a trail. So repeating again, B to C, C to D, D to B. 3 is completed. Now B to A to D. That's all. You don't have to come to the initial point B. So this is Euler trail as well as this is semi-Euler graph. You will not find a circuit there, and you can check the degree of D and degree of B is 3, and hence you will not find a Euler circuit as in the definition, that if and only if a graph has even all the degrees of the vertices are even. Sorry. Now let us recall some points in this short tutorial to check whether any graph is an Euler graph or not. So first, the graph, you have to check the graph is connected, contains Euler circuit, then it is obviously Euler graph. Otherwise you have to check all the vertices of the graph, all the vertices of the graph should be even. Now second note, to check whether any graph contains an Euler circuit or not, just make sure that all its vertices are even degree. If all its vertices are even degree, then the graph contains a Euler circuit. So this is the converse case, and for a semi-Euler graph, as I mentioned, it should be the graph should contain a Euler trail. Now yeah, in note 4, just make sure that the number of vertices in the graph with odd degree are not more than 2. To find a Euler trail, it is obvious that there should be 2 vertices of odd degree, as in the case of this picture. You can see that 2 vertices are of odd degree, B and C. It is required because you have to start from one and should end to the other, and to cover all the edges. Now another observation you will find, so an Euler graph is definitely the semi-Euler graph as it contains Euler trail, but a semi-Euler graph may or may not be an Euler graph. Now in home you have to check these figures. There are 6 figures, please note down, and you have to check these graphs are Euler, semi-Euler or not. So you can check either by degrees, or you can find some Euler trail and Euler circuits. Thank you for this. Thank you for listening this tutorial. গলাটা খুব ধরে আছে, সেই জন্য পুরোটা নিতে পারলাম না। নেক্সট ক্লাসে বাকিটা নেব। বাই।